Alright, so basically I've made a video the past couple of weeks about just the suspension, explaining how it will work in acceleration and during braking mode. And the cool thing about that is that the hydraulic lift system that is in the car is kind of the big thing in, just the big step up from what usual car makers do. They do have lift systems most of the time, but the purpose of these lift systems is not to increase acceleration or deceleration. It is to get over speed bumps and maintain a low ride height when you're capable of having a low ride height. So the other thing that I can do with this hydraulic system is also tense up these anti-roll bars and also make them softer or stiffer, or have them locked in a certain place at a side in a certain ride height. So those are also the capabilities that this system has. So that is what I wanted to demonstrate this time around for this video. So yeah, let's just get to it. I'm just prepare the model because, as you can see, there is a shit ton of parts in just this configuration, this car model. So everything from the engine, and for the people that are using SolidWorks, I guess you could kind of look at just the way this is set up and yeah, see how many parts are actually in the car. So yeah, and here go the gears and all of that. So it continues to go. So there's like synchro mesh parts for the gearbox, wishbone arms, ball bearings for the suspension, all the parts that are involved with the anti-roll bars, certain just joints and everything, the individual wishbones, suspension. Oh, these are the wheel carriers that's supposed to be put in here. This is just one spring, but there are 4 more spring and damper units. So, and it just continues and continues and continues. So there is just, as I said, a shit ton of parts in here. So I am just gonna take away everything that is like behind the monocoque, and yeah, see you guys in a second. So before I start, I just wanted to give you guys a quick disclaimer. You will see a lot of suspension movement with these parts that wouldn't happen in a regular situation, simply because SolidWorks does not know how friction works and does not know how pressure on the ground works with anything. So those are just things that I can't really maneuver around. So you will probably see sometimes me moving one suspension arm and the other one will move when it's not supposed to, and other times everything will go correctly. And please just ignore it and just follow the conversation that I'm having, and or maybe like the monologue that I'm having, and just please take my word for it. So yeah, first of all, this is basically a pull rod system. So what would happen if I would just turn these wheels straight? So that is basically also how the steering works. So that will come in a later video. I will also make a steering rack and with the pinion gears and all of that. So we'll see how that works later on. So this is now semi-straight, and so this is a double wishbone system setup. And what is unusual, which you would usually find in most other cars, is that the top wishbone is actually, this top wishbone is actually shorter in size than the bottom wishbone. And the reason why I didn't do this is because just space wise and everything, I just wanted that wishbone to connect here. And I know for suspension setups it's usually better to have a longer bottom wishbone, because that would kind of increase the camber angle when that wheel is going up and off in the ground. So that is when it goes under pressure, also in corners and everything. So that is something that is not optimum in this configuration. So that is one of the things that I should probably have another look at, and maybe find another way to mount this top wishbone in a way that this lower wishbone is actually becoming longer. So whatever. This is the pull rod mechanism. So this is a pull rod that is, by these ball joints, is held up to the top wishbone, and every time the top wishbone will move up, it will drag this pivot point, this triangle, and yeah, this will just turn around this pivot, and it will kind of drag this yeah, just spring and damper unit to be a pull moment instead of having it being pushed on there. So if you would want to see how that works, if yeah, this goes up. Come on, let me find a better angle. Maybe just like that. You can see the wheel move up if I drag this down, and you will see that the spring, if in a situation where I could actually let the spring move, instead of it going through this wall right here, it will be compressed. So that is one of the things that will happen in this pull rod mechanism. So when the wheel is going up over a bump or whatever, that spring and damper unit, instead of it being pulled towards each other, is kind of being torn apart. But that that separation movement will then compress the spring. So that is kind of the thing that I came up with this cage mechanism over the spring itself. So that is basically what happens. And so this is just a spring damper unit, and the main thing that this does for a car is that it keeps the center of gravity very low and also really in the center of the car. So this is basically one of the biggest things that one of the biggest benefits of this pull rod system is that it's just very low in the car, and it also really makes the spring and damper unit and everything, which is a pretty heavy unit, and it really makes it part of the sprung mass instead of the unsprung masses. So it's not something that is bouncing around in the car, and yeah, so the car really has all the weight is really attached to the body of the car instead of it being suspended in the air and then having a secondary moment attached to it when it's trying to move around and everything. So that's basically the biggest benefit of having a push rod or pull rod system. But in this case, with a pull rod system, it's even a bigger benefit because you keep all that weight very low to the ground. So that is the first part of just the pull rod suspension. The second part is that with this is basically just a piston, a hydraulic piston, which I can move out and in. And if with the previous videos that I made on the ride height with the acceleration and everything, you can lower and make the car higher and raise the car with pulling this piston in or dragging it out. So for instance, if I drag it out, and this is one of the things that I mentioned, because if there's not equal pressure on this car, so weird things will start to happen. But let's just say that I pull this thing out. I don't think it will go any further than that. You can see that the car is raised up in the air. The suspension arms are a little bit more towards the ground, and when I drag it in again, you can see that it will start to move up. And if you can get an equal movement going from this side, so like that, you can see that it is right now very low to the ground. The wheels are really almost yeah, they're pretty high off the cars just being lowered in this way. So that is one of the things that I can do, and with this ability I can, and also with it being attached towards a hydraulic piston, you can lower the car and raise the car in a very split second in a very short amount of time. So when you're on a racetrack and the car notices that you're not really putting in steering input and you're going in a straight line and you're about to enter your braking zone, as soon as you touch the brake, the car can just higher the front, lower the front, higher the rear of the car, make the front suspension softer, make the rear suspension stiffer, and as soon as that braking momentum starts to go, it can just let that center of mass lean a little bit forward, and then when the braking hits, that dive starts to happen, and with an increase in front downforce with the splitter also being very close to the ground, you will get a braking increase in performance, in braking performance. So that's also one of the things that you can do with a system like this one. So that is with the braking and the changes in ride height. If, let's say, this anti-roll bar, if I just drag it out a little bit more to increase the ride height of the car, and do the same for the other side, and now I can basically say that I want this anti-roll bar to be in a lock position. So I'm gonna just take these two together and lock them. So now this piston can be retracted or extruded anymore. So this would be in a track setup. So now that it's locked, I can kind of explain a little bit about cornering forces and all of that. So when you say you're in a car and you want to make a left-hand corner, it can kind of feel like you're being pulled to the right, but actually that is just your center of mass and the center of mass of the car that wants to continue moving in a forward direction, because that is just the way the direction of the kinetic energy of the car at that moment. So if you at that moment turn your front wheels to the left to make a left-hand corner, all of that weight continue to push forward. You'll start to lean on that right-hand tire. So that is also why you feel like you're being dragged to the right. So all of that weight momentum and that weight transfer will fall on the right-hand side of the car, and it will kind of make the car also lean towards the right and pulling the front left tire off the ground. And this is something that you want to prevent at all times. You want to keep equal pressure in cornering situations. So on all 4 tires, so that you have the maximum contact patch attached to the ground with the maximum amount of force on. So let's say we make that left-hand corner. So this right-hand tire will then start to move up and the left will start to come down. But if you have a big massive anti-roll bar, which cars usually have, street cars usually have, then they would kind of copy the movement of this wheel right here. So if you have just an anti-roll bar that is connected at a point somewhere here and goes down and then is attached somewhere here. So when this wheel is coming up, this wheel will also go up, and this will keep the car in balance, but it won't really favor that momentum because the car still wants to rotate towards this side. So instead of raising both wheels in that cornering momentum, you can also raise one, pull one down to keep it attached to the tarmac. So that is basically that's just the choice that I've made. So let's say we're taking that right hand turn and this wheel is being just pushed in the air. Just watch what happens to that left hand tire. You will see that it is moving down. So when that car starts to lean a little bit, it will push that left hand car into the tarmac. So it will keep the maximum tire contact patch off of the ground, and you can see that anti-roll bar now having a slight angle. So in a situation where you're on a track, this system works very good because it's always just pushing a tire that is trying to be lifted off of the ground into the tarmac. So that is a passive situation. But during road driving, this system becomes very uncomfortable for a driver, because if in a track situation one tire is being lifted up, the other one is trying to be pushed down. But if you are driving on the road and you suddenly hit a speed bump and both of them move up, then the car and the tires and everything will suddenly become one solid unit with the rest, but with just the overall body of the car. So that complete shock, you will feel everything to the seat. So that is not a very comfortable situation. So let's say you are driving just on the road and this tire right here is is just on a smooth patch of tarmac. So nothing is being disturbed with that tire whatsoever. But this tire right here, you're driving over cobblestones or whatever. Let's say you are in a part of Rome or just a medieval town somewhere. So what I've done now is I've just locked this wheel in place, so this wheel can't move right now. I can try to do whatever, but it's fully fixed. And I just wanted to show you guys that this hydraulic piston can now become part of your damping system. So you can now see that this hydraulic piston will now become part of your damping system. So as you can see, this wheel can just independently move however it wants to move, but the right front tire, so in screen left, is not moving at all, and this hydraulic piston is also being moved in and out. So it's essentially becoming part of your dampening system. So on the street, this can become a very comfortable system. And so as soon as that damping is soft from that hydraulic piston, the car will become very just soft, and all wheels can just move individually on whatever road you are driving on. And as soon as it becomes stiff, it can be very well balanced on track and have just a very centered car that just will have some body roll, of course, and that is natural and actually also good for a car to have some body roll, because that outside tire, if you can put more pressure on the outside tire a little bit more than the inside, that is a good thing for cornering, because that is also where the power will be, the grip will be. But you also still need that contact patch on the left front tire, so it's also good to have some pressure on that other wheel. But so in a track situation, that is very beneficial. So we now found a very good compromise between the two. So to kind of take a specific car as an example, there is a Ferrari F12berlinetta, not Berlinetta, the TDF edition. What they basically did to this car is they didn't only add like horsepower and take away some of the weight of the car, they also increased the width of the front tires by, I don't know exactly by what amount, but I believe it's either like a 275 width front tire, millimeter front tire, or 305. But this is extremely wide for a front tire. But the problem that they ran into with that car is that now, because the front tire patch is so aggressive on the ground, that the front of the car is trying to basically, the cornering speed the front of the car can achieve is basically outrunning what the rear of the car can achieve. So what they had to do to kind of make the rear able to keep up with the front in cornering speed and changing directions and all of that, they added rear wheel steering to do this. But just to use that as an example, by saying that you can kind of you can affect the way the car drives by taking a weight grip on the front, so in order to keep that damn, it's hard to explain. So just let's say instead of that rear wheel steering, it didn't have that, then the car would constantly drift around and be uncontrollable, presumably. So what they could have done is then just move back towards the old way of doing things and just take a weight grip from the front to make sure that the rear of the car is actually keeping up with the car. So by saying this is that you can increase the grip of the complete car by taking a weight grip on the front, and this might kind of maybe this won't really increase your lap times, because that grip on the front might help you to have some higher cornering speeds and everything, but this will help you to get a better, enjoyable and better driving car because it's more in balance. So that is basically the thing that I'm trying to say. And with this system, because the third step of this anti-roll bar mechanism is that you can have it very loose and completely loose and have no hydraulic resistance at all, or you can just completely lock it up for track driving. But let's say you're just on a road and you don't want it to be completely stiff, and you also don't want it to be completely loose. With this hydraulic pressure, you can also set up a mid-weight, or maybe many variations, many steps of just how stiff you want this anti-roll bar to be. So by taking away maybe grip from the rear and putting it more towards the front, you can have a car that is a little bit more drifting. And by maybe having it equal on both sides, you can have a car that is just very stable and very grippy. Or maybe you like a car that is a little bit more understeering. I don't really think that any car people really want a car that's understeering, but let's say you would have, or you do want that, then with this anti-roll bar mechanism you can do that by just making it softer on the front, stiffer on the rear, and making it more grippy on the front, more loose on the rear, and now you have a car that's drifting around all the time. So that is basically the third way, the third thing that you can do. So those are all the benefits from the system, and even though I'm the person that came up with it and it's pretty egotistical and arrogant to say it, I think it's very genius. So that is basically how it works. So yeah, I don't think I can add any more to that statement. And yeah, just next up will be the steering. And on the rear, I'm actually using the same wheel carriers on the rear and on the front. And what this allows me to do is that because of these ball joints, instead of having like locked just hinges, instead of having these hinges that the suspension arms are resting on, I have these ball joints here. And this gives me the freedom to choose if I want maybe some steering on the rear, some rear axle steering. So I'm still debating this with myself if I would want to do that, or if I just wanted to keep it a mechanical system that just has front wheel steering, because if you want rear steering, it's like an electrical motor setup instead of having a direct linkage between the steering wheel and those rear tires. So that is something that I'm still debating if I would want something like that on the car. So yeah, that is up next. So I think somewhere tomorrow or in 2 days I will have the steering done, and that will be a mechanism that is basically just a rat like this one attached to this point right here, and that will be somewhere around here in this area there will be a rack and pinion gear that will come down from a shaft that is bolted to a steering wheel here. So I'm debating if I'm making a steering wheel first, if I am making that rack and pinion gear first, and all of those things. So that will be the next part. And then after that I'm doing brakes, and after brakes I'm doing the final touches on the engine, Then I'm doing the final touches on just the cooling system for those electric motors and the batteries and all of that. Then I'm doing the actual battery itself. And after all those steps are completed, and I think that would be another 2 weeks, hopefully less, then I will start the body work. And that is my personal most my personal most exciting moment for the car, because you know, when all falls down, all comes down, I love doing body work way more than I love doing this stuff, but I feel like I need a solid, just something to work on. I don't just want to create body work, I want the body work to have a purpose and to be shrink wrapped around just a functioning car. That is just the way I create these things. So yeah, that is basically it. So thanks for watching. Please leave a like or subscribe to this YouTube video, and let me know if you have any thoughts on the suspension setup, and if you have maybe anything, a tip for me on how to do certain things. And yeah, I'd appreciate all the love. So I'm out.